Okay, now you're standing on the Burj Dubai, which happens to be on planet Mercury. The gravitational pull of gravity is 3.7 meters per second squared. Okay, don't worry about this. This is just a unit of gravity. So you know when you talk about the length of the string, you're talking about meters. If you're talking about an area of something, how much space something takes up, you're talking about meters squared. If you're talking about time, the time it takes to do something, most scientists they like to use seconds. Okay, so how long does it take for the brick to fall? Blah blah blah. Seconds. Well, gravity. Well, the unit of gravity is meters per second squared. So don't worry about this too much. Or sometimes they would write it like this. Okay, so you would see this 3.7 meters per second squared, or 3.7 meters per second squared. Don't worry about this too much. It's just a unit of what's called acceleration. Well, anyway, gravity is 3.7 on Mercury. So we are going to drop a brick from the top of the Burj Dubai, which happens to be on Mercury. How long will it take for the brick to hit the ground? Oh, if there happens to be an alien on 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 this planet here, you will know that their favorite food will be Mercury. Get it? Mercury. Never mind. Just find out how long it takes for the brick to hit the ground. So start off by writing the formula G(T) squared over 2. So here's our magical formula. We don't know how the physicists got to this formula. We just know how to use it. So press pause and have a go. Okay, the height of the building is 828. So put that into the H here. So that will be hang on, 828 equals GT squared over 2. We could put the G. Sorry, we could put 3.7 into the G now, but I'm going to leave it to the end. Now times both sides by 2. Hang on, let me take it down here. So 828 equals GT squared over 2. Okay. Now times both sides by 2. So hang on. 828 times 2 equals 1656. 1656 equals GT squared. Okay. Now you visualize this as G multiplying T squared. So kill off the G. Divide both sides by G. So it will be 1656. And now I'm going to put the G in. 3.7 T squared. Okay. So yeah, I'm now just putting the G in. So it should be this over G, and then I'll put 3.7 into the G. So it becomes this. Okay. Now let's just work out this bubble here. So this will become T squared. Hang on. Work out the bubble. So divided by 1656 divided by 3.77 equals roughly 448. 448. Okay, now square root both sides. So square root this, and then this on the right hand side it will be t. So that will become so now square root this number, square root it. So it would be roughly 21. Okay, roughly 21. So t equals 21. So what that means in our original picture here, 21, wasn't it? T equals 21. Yeah. So in our original picture here, if we were to drop a brick of not type A, of Burj Dubai, it would take 21 seconds for the brick to hit the ground on Mercury. Remember, on Earth, in one of the previous videos, we worked it out to be roughly about 13 seconds, somewhere near there. On Mercury, because the gravity, if you look at the gravity here, it's 3.7. It's a lot weaker than on Earth, which is 9.8. So it's, you can imagine gravity as being the strength of the pull towards the ground. So on Earth is 9.8, and on Mercury it's only 3.7. So the pull will be weaker. So it would take longer. So on Mercury it would take 21 seconds. If you happen to build the Dubai Tower on the moon, the gravity on the moon is 1.622. It's even weaker than Mercury, so it would take longer than 21 seconds. You can use that formula. You can use this formula here to work out how long it would take on the moon or on any other planet. Just use the internet, search up gravity, and then type in the planet like Mercury or whatever, and then look for this symbol here. Well, not this unit here, meters per second squared, or this one here. Look for this is just so that you know they are talking about gravity or acceleration. Don't worry about the word acceleration for the time being. Gravity is measured in this unit here. So look for this unit and then look for the number in front of it. Okay.